Good, marvelous Monday, geometry guys. We're back in Mr. Jeffrey's classroom. Don't forget, hit like, hit subscribe at the bell. Hey, just going to let y'all know, I actually, over the weekend, got multiple messages, even a few phone calls from parents from the school I came from begging me to come back. Like, sorry. So, yeah. All right. So, a biconditional statement is formed when a true conditional and its converse are combined. Okay? Now, some of y'all there are like, why are we still doing these weird Hey, hey, you are literally like right beside a plug. Is there two things there?
It's like covered. That's the left thing. It's not a plug-in thing.
Like, is it like a plastic cover? Like, can you unplug it?
No, it's like screwed in.
Okay. All right. We'll figure it out. Just sit them right there. We'll give them to somebody. All right. So, just chaos in the classroom. We'll get it plugged in here in a second. All right. Now, biconditionals often contain the phrase if and only if. Okay. Now, some of y'all are going to be able to use these in some of your little arguments that y'all have with all you people that are jumper cables. Y'all know jumper cable people? They're always starting something. Okay, they want to start the drama just to be part of it. All right. So, the given conditional is true. Write the converse of the conditional. Tell whether it's true or false. If the converse of is true, write a biconditional. Okay. And it says if the converse is false, explain by a counterexample. All right. It says if two angles are supplementary, then their measures are 180. So the converse of that, remember that's where you swap the stuff with the if and then, says if the measures of two angles totals 180, then the angles are supplementary. All right. So now this, of course, would be true. Okay, so it's true. Now the biconditional is two angles are supplementary if and only if their measures total 180. All right, so basically this is what happens. You have your conditional statement, your if-then statement. You make a converse of it. And if the converse is true, basically the if and then go away and you add if and only if. If this doesn't make sense, remember, what did they use like Tylenol? Opium. And opium is what they make heroin and stuff out of. They were on drugs, okay? So, all right. So now, this is kind of how it rolls, okay? Now, so everybody got this written down. Escribe por favor en sus papeles ahora. No habla español. I said write this down on your papers now, please. Escribe por favor. Write, please, on sus papeles, on your paper. Ahora, now. Do y'all take Spanish? Okay, I didn't know.
Yeah, I was lost whenever you started talking.
Some of y'all are lost when I start talking regular English, so I just. So, alright. I think that's got everybody now. People seem to be trying to touch each other and joke around, so, yeah. I've never understood why I have so many guys touching, like, other guys all at the same time. Like, that's their thing. Alright. So, example 2. Same thing. Alright. We're going to write the converse of this, and we're going to see if it's true. Okay? If it's true, then we're going to do an if and only if statement. Alright, so the conditional is if an angle measures 120, then the angle is obtuse. Well, the converse of that would be if an angle is obtuse, then it measures 120. All right. So, where am I going? All right. So, is this converse true? Is all obtuse angles 120? No. So we would actually just say false. Ooh. Make sure I had the right thing. Alright, so if it's false, we'd give a counterexample. You could use any obtuse measure that's not 120. I went with 130. Okay? Just with that, it's false. Alright, it says write two statements represented by this. Basically, it's asking us to write an if-then statement and then the conditional and then the converse. It says a number is divisible by 3 if and only if the sum of the number's digits is divisible by 3. I probably should have picked a better example. So the purple is the conditional. Okay, we'd say this is the conditional. This would be the converse. Okay. So basically we're wanting you to know these rules forwards and backwards. Get it? Because the converse is the reversed form. No? Okay. Womp womp. Hey, did y'all know that scientists have successfully crossed a watermelon and cauliflower? Yeah. They say when people eat it, they get the sense of sadness called melancholy. They're like, you're terrible. All right, so now we're not really digging into what these say right now. Okay, it's not a deep thought. of the day, why would you add the numbers to see if that's divisible by 3 to think if the whoever came up with this rule had to be on drugs. Okay, because this is like one of the most profound, crazy things I've ever seen. All right. All right. All right, just about got it. Just about. I know some of y'all are like, I'm writing way too much. Yes, I know. This is just one of those things. We got to check that box and move on. All right. So, now, believe it or not, there's a whole section of how to do this stuff with these conditionals and everything just using symbols. I've taught that before. We are not going to go down that road. Okay? Trust me, some of y'all would get lost. Symbolic notation for biconditional is the double arrows. That means if and only if. Means if it goes forwards and backwards. Okay? A good definition is reversible. Okay? So it says, what the heck was that? Alright. So it says, is this description of a triangle reversible? A triangle is a polygon with exactly 3 sides. If a polygon has exactly 3 sides, or if a figure is a triangle, then it's a polygon with exactly 3 sides. Alright, so now again, I'm having to borrow a lot of these notes because it's been a hot minute. Stupid me, back when I last taught geometry, like back in 2014. Yeah. I was like, I won't teach this again. Delete. Maybe it's 2017. I don't know. Alright. It's converse. If a figure of a polygon has exactly 3 sides, then it's a triangle. Alright. Are both true? Yes. Is the description reversible? Yes. That means the green is the first, blue is reversible. And yes, it's a definition. Alright. So, did you just knock that student's writing utensil out of their hand?
She makes us not feel
Alright. You'd be surprised how many pencils and pieces of pencils I pick up at the end of the day. Alright. Almost done with the lesson. Whoop whoop. Alright. Last example coming up here in just a little bit. I know you are excited. You can hardly contain yourself. Alright. Is this description of a right angle reversible? A right angle has a larger measure than any acute angle. Okay, so if we write it as a conditional, If it's a right angle, then it has a larger measure than any acute angle. It's converse. If an angle has a larger measure than any acute angle, then it's a right angle. Yeah, somebody already answered the thing. Are both true? No. Is the description reversible? No. Does it qualify as a definition? No. All right, because it says then it's a right angle. It could be 91 degrees. That's our counter example. Okay. All right, so we have a couple of practice problems to do in class, and then we're going to, throw somebody out the window. It's going to be a good day. All right. So, what? Oh, okay, now people are paying attention. All right, so don't forget, hit like, subscribe, hit the bell. Good stuff, good things. Roll Tide.